Hello all, and welcome to my presentation on Jeffrey McKee's Sparing Nature, the conflict between human population growth and Earth's biodiversity. In this presentation, I hope to shed some light on key topics from McKee's book and offer some balance into supporting and opposing views of the human impact on nature, particularly the questions regarding human overpopulation and how we are impacting the very important species we share our planet with. I hope to offer a critique of McKee's work from the viewpoint of other scientists who influenced him. Jeffrey McKee is a professor of anthropology at The Ohio State University. According to his book, Dr. McKee has spent much of his career as a field scientist working in remote locations in South Africa and China. Dr. McKee brings a fresh perspective to the idea of overpopulation. Being an anthropologist with specialized experience in hominid evolution and paleoecology, along with physical anthropology, Dr. McKee is able to look at human evolvement from the very beginning to see where we are today. Sparing Nature is a frank and decisive narrative on the effects that humans have had on the nature that we share with other species. To a point, McKee blames nearly all of the woes of species eradication on humans, whether it be habitat destruction, species invasion, pollution, exploitation, hybridization, or disease. McKee states that humans are at the source and has been for over 2 million years. McKee is a self-proclaimed, unashamed neo-Malthusian who believes that humans are well on our way to outgrowing our resources. In his book, McKee presents 3 propositions which become his Sparing Nature thesis. McKee states that there is a close relationship between biodiversity loss and human population growth. As more and more humans inhabit more and more land, the inevitability is that some species are going to be forced aside to live in reserves or in non-indigenous locations. This proposition is rarely disputed. The fact is that humans are indeed affecting other species. McKee's second proposition answers the question of if we want to conserve biodiversity on the Earth and how we shall go about doing it. The answer is to slow or halt the growth of the human population. I think most people, particularly those in the environmental sciences, will all agree that conservation of all species is important, but the cessation of human growth is difficult to apply. Even McKee acknowledges that procreation brings joy to humans, either the physical act of sex or the elation of bringing a new baby to the family. Limiting that joy is problematic. The third proposition in McKee's book is that conserving biodiversity is healthy to the planet and is therefore vital to humans. This is explicitly correct. Biodiversity is responsible for everything that sustains human beings, from creating the oxygen we breathe to pollinating the crops we eat. Every species, both large and small, helps to fulfill the human destiny. To harm biodiversity ultimately affects human health. McKee cites the noted ecologist Charles Elton's 1958 book, The Ecology of Invasions by Animals and Plants, to help persuade the reader why his 3 proposals of his thesis have merit. The religious and aesthetic reasons are purely personal, but the practical reasons are necessary to life as we know it. Sure, the religious belief that all life forms have equal rights to exist and the aesthetic beauty brought about nature are hard to ignore, but the practical benefits of biodiversity are something that better not be ignored. From providing soil for farming, timber for construction, or filtering greenhouse gases from the air, biodiversity in the planet's boreal forests provide much of the sustenance that has gotten us along this far. McKee helps to describe the human population conundrum by using Charles Darwin's metaphor of the human wedge. Natural selection is thought to be the driving force, and each individual wedge is the vast variations of species. But McKee helps make his point by claiming that each wedge is actually the more successful species forcing or wedging their way into lower level species, displacing them along the way. So is there truly a population problem? Let's look at the chart. Today, there are roughly 7.7 billion humans roaming the planet. When McKee wrote Sparing Nature, there were about 6.4 billion. That's a pretty sizable jump in just 16 years. About 81.25 million people added to our ranks every year. I wanted to take a look backwards to the year I was born. In 1968, there were only 3.5 billion people on the planet. In just the half century that I've been here, 4.2 billion people have joined me. That's 84 million people every year. Sort of makes you feel insignificant, doesn't it? Looking at the net increase column, it's not hard to see that we are gaining exponential population growth as predicted by Thomas Malthus, who we will discuss in a moment. So what does this mean? Does the Earth have a true maximum capacity on how many people that can be comfortably sustained? I remember a science class in high school where the teacher illustrated the capacity of a vessel. He filled the vessel with rocks and then marbles and then sand and finally water to show that every time we thought the vessel was full, he could add something more. Is the Earth like that? Can we continually add more and more people? Most scientists think not. Most reading yields that we are destined for failure by the time the Earth reaches somewhere between 9 and 11 billion people, depending on whose opinion you read. And my belief is that at some point, we as a species are going to eventually reach our maximum level of ability to live comfortable and fulfilled lives. Thomas Robert Malthus published his theory of exponential population growth in 1798. Based on the chart we looked at earlier, the Earth was very close to the 1 billion mark, and Malthus was concerned. His theory states that human growth was growing exponentially while our resources, particularly food, were only growing arithmetically, meaning that the humans were ramping upwards in a logarithmic projection while the food growth was continuing on a straight line course. At some point, that curve and that straight line would intersect, creating the Malthusian catastrophe, the point where famine would begin to decrease the population. The Malthusian catastrophe looks like this. Over a linear amount of time, the exponential population growth will rise faster than the arithmetic production of food product, intersecting somewhere around the 10 billion people mark. Now, I don't believe Malthus predicted 10 billion people ever inhabiting our planet. How could he? That was over 200 years ago. But I do believe he accurately predicted that our population was going to ramp ever upwards and reach cataclysmic levels at some point. Was Malthus correct? Are we reaching the Malthusian catastrophe at some point? There are those who don't believe so. Meet Esther Bostrup, the noted Danish economist who in 1965 published The Conditions of Agricultural Growth, the Economics of Agrarian Change Under Population Pressure. Ms. Bostrup believed that humans were adaptable to any condition and would find a way to produce enough food. She believed in a theory known as agricultural intensification, where as more demand required more food, farming techniques would rise to the occasion. She challenged Malthus using the very fact that humans had already grown to almost 3.5 billion people since Malthus' era, and she believed that agricultural advancements would keep pace with the growing demand. If we plot the two theories on a chart, we can see that both Bostrup and Malthus agree on the rising exponential growth of humans, but where Malthus has the food supply intersecting the population, creating the Malthusian catastrophe we discussed, Bostrup believes that an increasing population drives crop intensification, which will step food production up along the population curve. Bostrup had reason to believe this. She had lived through the Green Revolution, the period of time where scientific and mechanical advancements had lent themselves to much higher crop yields on the same plots of land. More food grown on less land has already happened, and Bostrup believed it would happen again. A linearity fallacy exists when it is expected that one function of a relationship will remain linear when the correlating function will act exponentially, when in fact both functions act exponentially and independent of one another. Malthus assumed that food production would remain linear, when in fact with the advent of mechanized farming and genetically modified crops, we see that the farmers are able to grow even more food on less land than was possible in Malthus' time. Bostrup assumed that all nations would continue to adapt to intensified agricultural techniques, not realizing that underdeveloped nations would not be able to grow food at the same level as other industrialized nations. Both scientists had fundamental flaws in how they processed the comparison of linearity and exponential growth in either population growth or in agricultural advancement. Many consider that we have entered into the epoch of Anthropocene. This is the time where man has a direct influence in all matters of our biosphere. As we proceed further into the Anthropocene, it is important that humans use their greater skills to protect the lesser species that provide fundamental ecosystem services that are vital to our health and nourishment. Humans are already starting off on the wrong foot as we've entered the Anthropocene. Global climate change, greenhouse gases, depletion of fossil fuels, eradication of necessary species, increased urban sprawl, all of these are issues that are a direct result of overpopulation and poor management of resources. As humans are in control of our biosphere, we should protect the biodiversity that is necessary to sustain us. Humans are the obvious detriment to our present situation. And as Bostrup indicates, it is going to be our innovation and ingenuity that gets us through the population crisis. Thank you all for attending my presentation. Here are some citations that you can review.